Hi, everyone. My name is Priya Venkat. I'm a senior manager of AI at Intuit. My teams build ML and AI models for TurboTax and other financial applications. Recently, we have deployed a lot of several agentic AI applications. Today, I'm going to be talking about evaluations for AI agents. I think building AI agents has been democratized a lot recently. It's really incredible to see the agents coming out every day. I think folks, I think folks have, been publishing a lot of work related to how they're using agents, how they're using vibe coding to create agents and so on. And a lot of it seems to work great the very first time, which is incredible to see. But what happens when you want to deploy things in production to hundreds of thousands or millions of customers, and especially to paying customers who are going to come after you if you're not providing the services that you're claiming to provide? What if you're building AI tools, or even if you're just someone who wants to understand why your favorite AI suddenly feels worse after getting an update? Understanding evaluations or evals is the ultimate workout that you can do. Because if you don't understand how these systems are actually graded, then you cannot understand why they behave the way they do out in the wild. So today we're going to, talk more about grading an autonomous agent. And this is fundamentally different from the AI systems we had previously. So on the left, for example, we have these more predictable systems which are non-agentic, where you have maybe you're giving a prompt and a context to the LLM, you get a response, you have a grading logic, and you're going to say, what's the score that the LLM got on this particular question. And then you have a slightly more complex system where maybe it's not just one question and one answer. You have several back and forths, and it's sort of a chatbot. So I think there has been a lot of publications in the industry about how to evaluate those as well. And then on the right, one step further, where we have agents, where you have it's gone further from one question, one answer, or even back and forths. Now it is an agent that is able to invoke several tools to get the job done. So we have to transition our thinking from what AI used to be to what it's actually today. So our baselines have improved a lot. Excuse me, sorry about that. Cool. So on the right, what we have really is a high-level task that you're providing to the agent. And then this agent is able to use multiple tools, external tools. They have to read internal files. They have to modify the state of the environment as they go and adapt based on intermediate results. So this is what we are talking about when we say agentic evaluation. If an agent writes a piece of code, tests it, sees a compiler error, then writes it, then that is a multi-turn process. And in that environment, your mistakes can compound. If you make a mistake at step 10, then it completely derails the rest of the process. So everything that I'm going to be talking about today is based on industry published resources on agentic AI evaluations, mainly coming from places like LangChain and OpenAI and Anthropic, right? So let me move on and give some core vocabulary about how we talk about agentic evaluations. And yeah, this is a nice slide notebook. Ella made it for me, but it's talking about basically a production failure, right? So you deployed an agent, it ran successfully. For 2 minutes, you gave 200 steps to follow, and then it failed. So let's go and debug it. Where is the stack trace? There is no stack trace. There is no what like you're trying to understand which line of code broke, but there is no code that broke because the agent didn't suffer a syntax error. It actually made a reasoning error. Instead of calling one type of file, it decided to call a different kind of file. And that single hallucination compounded over the next 177 steps until the entire system collapsed. Right. So when you try to understand why an agent failed, the source of that truth is not in your code base. It's hidden in the trajectory of the emergent behavior of the agent. So when we say emergent behavior, what does that really mean? When you write a piece of software, you know what you're asking the software to do. You know what the outcome is going to be. You have unit tested it, you have done the integration tests, and you have some idea of when it goes wrong, how it can go wrong. But with AI agents, it's almost guaranteed that they will go wrong. So the question is, what is the buffer for failure that you have, and how can you understand where this reasoning failure really happened? Cool. So, talking about the vocabulary of evaluations, you have this task. So task is basically you have a set of a specific test case with defined inputs and success criteria. Then you have a trial. Similar vocabulary is, probability. You have a trial, which is one single attempt at the task, because you're not going to run it once, right? You know, systems are stochastic. The output is going to vary over multiple trials. So the trial is one execution attempt, right? The next terminology that we have here is the transcript, right? And the transcript is basically the complete unfiltered record of everything that happened during the trial. Every output, every tool call, every internal reasoning step. It's almost like this black box that you have in the flights to record what happened, right? And the ultimate goal of all of this is to understand this outcome, right? Meaning the final objective state of the environment. For example, if you have a calendar agent, did the invite actually get sent out? Or if it's a refund agent, did the refund actually process, right? Those are the outcomes. And then finally, you have these graders. So the graders, it's combination of logic that looks at a transcript and the outcome and then decides whether the AI passed or failed. So this is well, there are still minor details within each of these boxes, but if you look for an overview, this is what the entire evaluation system looks like, right? So to give you an example, um, yeah, I'll leave the slide here, but I'll talk about an example that Anthropic mentioned in one of their blogs. It's about this Opus 4.5, where they were trying to understand what is the capability of 4.5. And we use several different benchmarking data sets to understand the performance of each AI model. So this 4.5 model, this agent was instructed to navigate a specific airline interface to book a flight based on a set of user constraints and so on. So what Opus 4.5 did, what the expectation was that the agent would go to the website, it will go through the UI, and it will click on the things that like a human would, and then finally book a flight. But what actually ended up happening was that it discovered a loophole in the backend policy and bypassed all of these clicking of buttons and was able to book a flight much faster by skipping to the end. So it achieved the perfect outcome for the user, But if you look at our evaluation system, the grader was actually asked to um, do check marks based on did the agent click on this button and then this button and these specific set of steps, right? So who is right here? Is the grader actually failed the agent for not following the steps, but then the agent was actually able to achieve the outcome for the customer, right? So this is the paradox of modern AI. The exact capabilities that make an agent so incredibly useful, their autonomy, their intelligence, their ability to find novel solutions, those are the exact same traits that make it a total nightmare to evaluate AI agents. So it's like you're trying to hold a static ruler against this dynamic creative entity, right? So what can we do? How do development teams know whether this shiny new agent that they have built is any good, right? We are hearing of agents getting pushed to production every single day. So what are teams really doing other than crossing their fingers? So I think most folks are aware when Gen AI started becoming mainstream, a lot of the dependence was, of course, on manual evaluations, right? So so if you look at GPT 2.5 and 3, a lot of the evaluations were in fact manual, and we're trying to see can we do some dog fooding, have several folks on the team try to understand the AI and so on, to to check box where a model is doing well, right? With agents, especially now that we have all this emergent behavior, you are not guaranteed to see something in your test environment that will happen in production environment. Or to put it another way, there are things that can happen in production environment that you have never seen in your testing environment before. Right. So that's the challenge that AI engineers today are trying to get around. Um, and you can get very far with just doing dog fooding and vibing and manual checks. But it can be a recipe for burnout because you're checking your system, you're testing your system, and then you find this particular behavior that you didn't anticipate, like this flight example. Then you try to put in guardrails in your prompts to make sure that behavior doesn't repeat. But then you do another round of testing and then you discover another behavior, right? So this is not sustainable for folks that are interested in pushing to production, being fast, and finding things along the way, right? And this is basically what industry calls the flying blind problem, because it's very difficult to scale when we don't have that kind of visibility into what can happen. So on this slide here, we have traditional software, how we are used to testing those, and then how we test AI agents, where the behavior is basically emergent, and a lot of the final outcomes depend on the path that the agent took to achieve that outcome. So we have the reasoning trace. If you're calling a tool for calculations, for example, because we know LLMs struggle with math, right? So if you're doing that, if you're calling a tool for RAG, where you want to ground your agent in a database, for example. So those can be the different types of tool calls. With the reasoning trace, you're really trying to understand which tool did the agent call for this particular user question, and what intermediate steps happened, and where is the reasoning context, right? I'll go back. Okay. Um, excuse me. So that's the kind of diagnostic tool that you have when you're working with AI agents. You've now moved away from these binary unit tests where you're having pass or fail assertions on predictable static outputs. Instead, you're having a trajectory analysis, right? And then in the agentic AI world, the role of production is really what is the correct behavior, right? What should be the test suite that we should be using to really understand how this agent behaves, right? I also want to talk about one particular, yeah. Um, this particular slide talks about capability evals and regression evals. What is this really? When you develop an agent, what can it do? What do you really want it to achieve? And what are the set of benchmarks that can help you understand that? Those are the capability events, right? So, you know, I let's say I built an agent for calendar, right? It has to send out invites. It has to um, appropriately understand where the availability is and provide scheduling times based on that and so on, right? So those are the kind of data sets that you try to use to understand the capability evals, how well your agent is doing with those tasks. And the idea is with time or with multiple iterations of the prompts or the model quality, the agent does better and better on these evaluations and gets to a quality threshold that you are happy with, right? Post that, anytime you make an update to the agent, either you're deploying a new feature or you're trying to give it a new capability, well, not a new capability, but um, you're trying to make an update within the existing agent to fix some bugs, let's say, for example, you again have to run these same evals, but now these are called the regression evals because you want to understand um, whether the agent is backsliding and giving you worse performance on something that it used to do good at, right? So, so the whole point of talking about all this is to say, instead of relying heavily on manual evals, if we can build an automated suite that helps your engineers have a clear hill. This is the mountain and this is what declining looks like, so that you have a reliable way to quickly iterate and fix things instead of doing a whack-a-mole and trying to fix each thing as it appears. Cool. So, and especially here, I want to talk about, sorry about that. I think I'm catching some bug. Especially here, I want to talk about one thing. There is a perception that evaluations slow down the path to production. I hear that all the time, and it feels like a lot of work. But it may feel slow in week one. But in my experience, it's the ultimate accelerator for development and model adoption if you're looking at 3 months, 6 months timelines. For example, let's consider what happens when a brand new, I think I had a different slide for this. Okay, yeah, I think this is more relevant. So let's say there's a brand new, massively powerful AI model, and uh, these two sets of folks who are trying to evaluate that AI model try to understand um, which features of theirs the AI model is going to be really good at, right? So the competitor who doesn't have an automated eval suite, they're going to spend weeks having their engineers, do manual evaluations and some vibes to see if it brings their specific application to a higher quality level. But then the team with the robust eval suite, they can just swap out the API keys, bring in the new model, do the automated tests over a weekend, find where the new model is strong, where it's not strong. We need to tweak our prompts and then ship an upgrade in a few days, right? So there's a massive competitive advantage simply because you can actually trust your own testing infrastructure, right? So it's a safety net that we can actually have. A little bit more terminology when we talk about agent observability. There is this run one single step, um, and then did the agent make the right decision at the specific moment? And then we have the trace, which is the full turn. There was a user input, there was a first LLM call, then there was a tool call, LLM call two, then what was the final outcome? So that's the entire trace, what a reasoning trace or just a trace. And there are multiple companies out there now that are providing these kind of surprise services to enterprise AI. And then the next level is really multi-turn. So this is a conversation session grouping multiple traces over time. Did the agent maintain context? Did it evolve the state? Did it remember the user preferences that was said in the first turn, for example? Those are the kind of things we're talking about over here. Um, um, So now we know what kind of evaluations we're looking at, what kind of evaluations will give us uh, a quantitative way to understand how an agent is performing. The next thing I want to talk about is the kind of graders that we have. So we are going to call out like three kind of graders. I think there can be more hybrid systems as well. But first is code based, right? For example, you're like think of a multiple choice question. You know the answer is A or B or C. So you'll just have a string match that says, okay, agent said A, correct answer is A. So we have the ground truth to compare and we are good, right? So code-based graders, these are the oldest and most familiar. They're fast because basically there's not much to run. They're entirely objective. On the flip side, they are brittle. For example, let's say like the grader is expecting a particular phrase for a particular question, right? If the user, if the agent actually changes a few words in the phrase, then it's going to say it's not correct, right? So these work when you are starting out, but and for specific use cases, but may not be the right for more complex use cases, right? Hmm. So then the next we talk about is LLM as a judge, which a lot of you may be familiar with, where you're trying to use a more powerful AI to assess the performance of the AI that actually produced the answer, right? Um, and here there is the concept of a tribunal, right? So let's break that down a little bit. Um, One AI is being used to grade the output of another AI, and these are incredibly flexible at capturing the linguistic nuances. They can evaluate highly open-ended tasks. And here's where it gets really interesting, because when we say you're using one LLM to grade another LLM, it almost feels like, oh, we had this, test and um, you're letting your classmate grade your homework or you're grading your own homework, right? So there is a lot of effort that has to go into calibrating that judge as well, right? And this is what, we call as alignment. And we also try to understand over different runs, how does this judge behave, right? Like the AI judge cannot be giving out, a on a test on Tuesday and a B minus on Wednesday, right? So we want that agent to be consistent across different runs. And another behavior of LLMs that folks might have encountered is that LLMs are people pleasers. They want to be liked. So again, so there is a lot of effort that has to go in to make sure that the judge LLM is aligned with how a human expert, not just any human, but a human subject matter expert would grade that particular transcript, right? Um, cool. And like the next type of grader is the human, which is the gold standard. They can do the SME review, they can spot check the sampling. But there's also this issue of two different humans may not rate the same item the same way. So we talk about inter-annotator agreement, and ideally that score has to be pretty high for us to trust that this task we have gotten it to a stage where we can be aligned across human judges, and then we can talk about the LLM as a judge. So what we are going towards for AI agents, it's not just one LLM that acts as a judge, but it's basically an ecosystem of accountability, right? Humans train the AI judge then can evaluate the AI agent. And this kind of like tribunal allows the team to implement like a vital concept from source all the way to production, right? And it does mean that each of those steps in between also have to be evaluated, including the tool that was chosen, the if the system said that this is out of scope for me, that has to be evaluated, and so on. Cool. I want to talk about this graph, which is also highlighted in the blogs that I mentioned from Anthropic. This is about what kind of metrics we should be using when evaluating agents. Not specifically going into whether it's a chatbot or a different kind of agent, but in the terminology of you have these trials and what is the success, right? So one of the metrics, like one variation of this is pass at k, and then the other one is pass to the power of k, right? So and the distinction here is pretty significant because it talks about the reliability of your product when you're putting it in production, right? So pass at K, I think, many folks may be familiar with that here. Basically, you have several trials of the agent. You run it one times, you run it 10 times, but you take success from out of the 10. So if it gets the correct answer in 10 trials, then you're good, right? Whereas pass to the K is about making sure that there is a success in every single try, right? So let's say for one trial, your agent has a 75% success rate or 80% success rate, which seems to be a threshold across industries. However, for one trial, your success rate is 75%, but then the next time you do the trial, again, you have a 75% success rate. So your error actually compounds, right? So if you run that same agent 3 times, then that 75% actually translates to 42% across those 3 trials, which does not look great when you're talking about how good an agent is, right? And we cannot take that 42% to production. Right. That's why this metric is so important, because it tells you how much risk you are able to take when you have your business on the line. Right. So this raises an important question that the that we need absolute bulletproof consistency across every single trial uh, to be able to have that confidence. For example, you're processing financial transactions, you're giving an agent that kind of power, right? Or you're talking about medical records. You really do need that kind of reliability before you can trust an agent and let it out in the wild, right? Cool. So that's all of that was about, how we think about evaluations. What does the entire system look like? What kind of vocabulary we use when we talk about evaluations? Uh, the next thing I want to talk about is how our engineers actually build a safety net and try to be prudent about evaluations and try to catch fatal errors before it ruins something in production. So let's go into that. Apologies. So this is a roadmap that I have for the different steps that you need to do to get to reliable evaluations. First is start early, start small. It sounds very simple, but a lot of folks don't do it. Um, so if you're going to build an agent, first write out the agent job description. This is what I need the agent to do. This is what I don't need the agent to do. And then come up with, maybe 20, 30 actual scenarios that the agent will encounter. So this could be from in collaboration with the PM or your own subject matter expertise or actual subject matter experts that can help. So here are the 20, 30 examples that where the agent actually has to work. And this is not necessarily new for agentic AI. For ML systems also, we have always been doing that, where you try to understand your inference time scenarios are going to be very similar to your training time scenarios, and you collect examples where you need your ML model to run. So it's very similar, right? So here are the 20, 30 tasks drawn from actual scenarios that may happen in production, and then use that as your golden data set, right? Then um, then you move to step two, right? You have you can have these like manual tests, and for example, you can have two human experts that would disagree on whether an agent passed the task. But then the reality is that the task is poorly written, right? So you have to make sure that the task that you wrote out for the agent is actually solvable by creating reference solutions, and then talk about whether the graders are aligning. Um, once you so with step one, what we're really talking about is you have built the agent, you started with a small data set, you have done some trial and error. Now you're actually trying to, before you put that in production, you have it in test, and we are going to do some user tests and use those bug trackers and support queues to automated test cases. So this is something we want the agent to do in production, make that into a test case, right? Prioritized by user impact. Then we move on to known reference solutions. So, for example, if you if you run a test suite and you're seeing that the agent has very low accuracy, um, it 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 does not necessarily mean that the agent is having low performance. It could also be that the the test hasn't been written in the right way, right? For example, in that flight scenario example, where the agent just bypassed all of the clicking and went directly to the backend loophole. So those things could be happening. So it's for us to be meticulous about building those data sets. And then finally, you have to test both when a behavior should happen and when it should not happen. So we're talking about some negative examples here, right? In the alternate um, uh, negative scenario, how should the agent respond? it should not respond this way. That is also important. A lot of folks, I think, when they build the test cases, they only talk about, oh, if these, if then the agent should give this response. But then they don't give enough examples of if things go wrong in between, what the agent shouldn't respond with, right? So, for example, yeah, one of the things that comes up a lot in my team is like, if you write a prompt, you also have to write a test to validate that that prompt instruction is actually being followed by the LLM, right? So it's easier to think of it that way. And then finally, one thing to call out here is if you're testing, let's say, a web search tool from an agent, the if you grade the agent higher on using the web search tool, it will learn that using the web search tool is what gets me higher scores. So I'm going to do that each time, even if the answer is very, very simple, right? So we have to guard against these kind of scenarios as well. Cool. The last thing I want to talk about is the Swiss cheese model of quality. So let me go to that, if I can find it. All right. So this is the last thing I want to highlight before closing. One way to not have, the whack-a-mole scenario and just testing. Let's create it. Let's do a UAT and then find out what the emergent behavior is. The more systematic way to think of it is the Swiss cheese model of quality, where you have layers with holes for quality, right? The first evaluation layer is your automated evals. That is created from a suite of what you have seen so far in test. This establishes the baseline performance and catches system regressions before deployment. The second layer is manual transcript and review, right? You have put it in production. Oh, what happened in the last few hours? Can we look at those traces? Is the agent actually behaving as we intended it to? That's your second layer, right? And then the third layer is production monitoring and user feedback. So here you are looking at, over the last week in production, what really happened? Did the user give a thumbs down? What scenario actually happened? That's your final layer of the Swiss cheese, right? So most systems, if they are doing well in production, very likely they have these layers stacked up, because even if you missed one issue because of the hole in your layer of Swiss cheese, another layer, there is a high probability that it will catch it. So, like one example is where, the automated eval suite that you created, it's basically only looking for behavior that you actually put in your prompts, and you think these are the kind of questions that a user would interact with. But then when, like, you can always rely on users to come up with behaviors that you did not mean to happen, right? That just always happens. So these other layers help you with a way to capture those scenarios, so you can, put in more guardrails, change your prompts accordingly, and so on. Cool. Yeah, so that's all I had for this talk. Thank you, everyone.